Hi friends, in this video we are going to discuss about the concept of Kirchhoff's voltage law. So here first we are going to discuss about the definition of Kirchhoff's voltage law, and after that how we can analyze or how we can solve the problems by using Kirchhoff's voltage law. Okay, so first we are going to discuss about the definition of Kirchhoff's voltage law. Just see here. So here the definition of Kirchhoff's voltage law is, just see, it is defined as the algebraic sum of all branch voltages around any closed path in a circuit is always zero at all instants of time. Okay, it is defined as the algebraic sum of all branch voltages around any closed path in a circuit is always zero at all instants of time is called as Kirchhoff's voltage law. Okay, so now we know the definition of Kirchhoff's voltage law. Now with the help of this particular definition, how we can verify this Kirchhoff's voltage law in any circuit. So now our target is to verify the same definition with the help of an example. Okay, just see here. So this one is the example first thing. So we have a circuit. So in this particular circuit, R1 and R2 are the two resistors and which are connected in series. So for the series connection of R1 and R2, so there is a applied voltage of Vt. So here V suffix T represents total voltage applied to the series RL circuit, series R1 and R2 circuit. Okay, so Vt represents the applied voltage, R1, R2 are the resistors and which are connected in series, and there is a flow of current I. Here the value of I, that is the current I, is flowing through the series combination of R1 and R2. So whenever this amount of current is flowing through R1 and R2, there is a voltage drop possible. Okay, so across this particular R1 and R2 there is a voltage drop. So the voltage drop across the R1 is this one. Okay, across the R1 is VR1. So this is the VR1, and across R2, so VR2 is there. So here these two, so these particular two voltage drops, if suppose we are going to add these two voltage drops, so we need to get the sum of these VR1 and VR2 is equal to the applied voltage Vt. Okay, so this is our target to get or to verify Kirchhoff's voltage law in any closed path. Okay, just see here again the definition of Kirchhoff's voltage law again defined here. It is defined as the algebraic sum of all branch voltages around any closed path in a circuit is always zero at all instants of time. It means that applied voltage must be is equal to the voltage drops across individual elements. It means that the voltage drop across R1 is VR1, the voltage of across R2 is VR2. If I am going to add VR1 plus VR2, the addition of or the sum of these two voltage drops must be is equal to Vt. Then only the Kirchhoff's voltage law is verified in any circuit. Okay, so like this we can verify. But to verify this Kirchhoff's voltage law, first we need to know what is the current which is flowing in the circuit. If you know the value of current which is flowing in the circuit or through the elements, so with the help of that particular current only, there is a possibility to find the voltage drop VR1, the voltage drop VR2. Okay, so that is the reason why. So we have formulas here, just see. So if you want to find the voltage drop across the R1 resistor, so we can directly use VR1 is equal to I into R1. Here R1 is the value of resistor R1 and here I represents the current which is flowing in the circuit. Okay, now this is the voltage drop across R1. Now coming to the voltage drop across R2. So here the voltage drop across R2 is equal to, so VR2 is equal to I into R2. Here I represents the total current R2 represents the value of resistor R2 which is given in the problem or in the circuit. Okay, so if you know these two particular values, then with the help of the definition of Kirchhoff's voltage law, we can write Vt is equal to Vr1 plus Vr2. So when the applied voltage Vt is equal to the sum of voltage drop across individual elements Vr1 and Vr2, if these two values are equal, it means applied voltage is equal to the sum of voltage of across individual resistors, both are equal, then Kirchhoff's voltage law is verified. Okay, so that is the reason why we can define the Kirchhoff's voltage law in another way. So that we'll discuss at the end of this video. Okay, so that one is the value of what, this one is a value of, so applied voltage is equal to sum of voltage drops across individual elements. Now this is the applied voltage is equal to sum of voltage drop. But what is this expression? So this expression represents the algebraic sum of voltages in a closed path. Okay, so that is the reason why. So this expression we are writing with the help of this expression only. So that is the reason why we are writing here Vt minus Vr1 minus Vr2 is equal to 0. Okay, so just see here the difference between these two expression. Just see, this expression represents applied voltage is equal to sum of voltage drop across individual elements. But here this expression represents the algebraic sum of voltage in a loop is equal to 0. So that is the reason why we can define the definition for this expression. We can also define the definition for this expression. Okay, so here just see the difference between these two. So if you want to define the definition of Kirchhoff's voltage law with the help of this expression, so we can define the applied voltage must be is equal to the sum of voltage of across individual elements in any closed circuit is called as Kirchhoff's voltage law. And if you want to define the definition for Kirchhoff's voltage law with the help of this expression, we can define, so the algebraic sum of voltages in any closed path is equal to 0. Okay, so that is the reason why we can define the two definitions for Kirchhoff's voltage law. Okay, so with the help of two definitions we can write the expressions, this one is 1 and this one is 1. Okay, so like this we can define the definition of Kirchhoff's voltage law. Okay, I think you are clear now. Okay, just remember definition of Kirchhoff's voltage law is clear, and how we are getting the expression of Vt is equal to Vr1 plus Vr2. So applied voltage is equal to sum of voltage of across R1 and R2. Here to find the value of Vr1 we require the value of total current which is flowing in the circuit, and R1 represents the value of resistance which is given in the original circuit, and here R2 is also same. So R2 represents the value of resistor which is given in the problem, but here Vr2 represents the voltage drop across resistor R2. So to find this particular voltage drop across Vr2, so we require to calculate the value of current I. Okay, so we know that we already discussed about this particular topic in previous class or previous video. So in that you know that how to find the value of current in any closed circuit. Okay, so just if you want to know about how we are calculating the value of current in any closed circuit, so just go to my YouTube channel and go to my previous classes, that is calculation of current in any circuit. Okay, so like this we can write the expressions of Kirchhoff's voltage law for any circuit. Okay, now coming to one problem, just see here. Now we are going to discuss about one problem. So that problem consisting of, just see, the values of applied voltage Vt is equal to 100 volts, the Vr1 is equal to 70, and here Vr2 is equal to 30. Now as per the definition of Kirchhoff's voltage law, applied voltage must be is equal to sum of voltage of across individual elements. So that we are writing Vt is equal to Vr1 plus Vr2, because in the circuit we have only two resistors. For example, in the circuit we have 10 resistors, then we need to write Vt is equal to Vr1 plus Vr2 plus Vr3 plus up to V10. Okay, so now we know the value of Vt is 100 and Vr1 is equal to 70, Vr2 is equal to 30. By adding these two values you are getting So here 100 is equal to 100. 100 is equal to 100 means applied voltage is equal to sum of voltage of across individual elements. So that is the reason why 100 is equal to 100. So we can write this expression in the second definition, that is sum of algebraic voltages in any closed path is equal to 0 means, so 100 minus 100 is equal to 0. Okay. So like this we can define any definition. Now coming to the another thing, that one is the definition, second definition. Okay, just see the second definition, that is this one. Okay, so it is defined as what? It states that in any circuit the applied voltage to the circuit must be is equal to the sum of voltage of across each element is called as Kirchhoff's voltage law. Okay, so we can define these two definitions for Kirchhoff's voltage law. Both the definitions are same. Okay, just writing the expression is different in both the definitions. Okay, so this is about the today's class, and I think you are clear with this topic. So in the coming classes I am going to solve some few problems based on KCL, KVL, Ohm's law, and how to find the voltage drops across any element. Okay, so don't miss the next upcoming classes. So for that, to get the notifications, just subscribe my YouTube channel for more updates. Thank you so much for watching, and please do subscribe my channel.